Okay. So today we're going to be doing the 10 graph. Now, as you can see, it looks different from the other two graphs. Now, it looks like a hyperbola, but it's not. But they're the same in the sense that it also has asymptotes. So an original 10 graph looks like this. So just like the sine graph, it also starts from 0. And it starts from 0 and ends negative infinity. Sorry. And it's got asymptotes at 90 and 270. And its period, the period is 180. I saw a lot of you guys got confused. Okay, the ones that sent me homework, some of you guys are confused. Period. Because others wrote 1. So remember, the period is the x values it takes to complete one full wave. So remember, sine, it starts from 0 all the way up to 360. Cos, it starts all the way from 0 all the way up to 360. But for this one, can you see here on this side, we do not have a full wave. And on this side, we don't have a full wave. The only full wave we have is here. And that wave is between 90 and 270. That's why your period is 180. Because if you say 270 minus 80, you're going to get 180. 270 minus 90, sorry. So that is why the period for this graph is different. It's going to be 180, as opposed to the cos graph, which goes like this. And then the sine graph, which goes like this. Those ones take the full length from 0 to 360. However, for this one, it's going to be different. I hope that makes sense. You guys have any questions? Then domain, remember, is the x values that are covered by the graph, or the parts of the graph for the parts of the x-axis for which the graph is defined, or its roots are real and true. Can you guys not hear me? Who's having a problem hearing me? Guys, can you hear me?
Yes, ma'am.
We can.
Did you hear everything from the beginning, or just different parts?
Yeah.
Yeah, but then we had everything.
Okay. So as I was saying, the domain is where the graph is defined, for all the x values for which the graph is defined, or the graph is real. So what that means is if you take the x value and substitute it into the equation of the graph, you should get an answer and not an error. So for example, in this graph, the 10 graph, if you substitute 1090, you're going to get undefined. Your calculator is going to say undefined, or it's going to give you a math error. Same thing with 270. If you put 270, your graph is going to say error or undefined. So that means the graph is defined, this graph is defined everywhere except at 90 and 270. So as you can see, the graph is defined 0 and 360 except at 90 and 270. Does that make sense?
Yes. Yes.
Okay. And then as you guys can see as well, right? As you guys can see as well, right? This graph does. Who's speaking? Okay, and then as I was saying, sorry, as you guys can see, for the y value, for the range, our graph goes from positive infinity to negative infinity. So you can, when you write the bracket notation, you can write that. You can write from positive infinity to negative infinity, not included. So that means you're going to write round brackets. Or you can just say y is an element of real numbers. That means any number that is real, from negative infinity to positive infinity. Because you can see our graph is ongoing. It doesn't stop. Just because this part we show from 0 only doesn't mean that even on the side, the graph goes on until it reaches an asymptote. But for y, it keeps on going down. Remember, the graph keeps on going down or keeps on going up. However, it will never touch the asymptote. So it'll keep on going up and getting close to the asymptote, but it'll never touch the asymptote. And we don't know where it stops. That's why we say from positive infinity to negative infinity, because we don't have specific values for infinity. Infinity can be anything. Infinity can be 8, it can be 3, it can be 1,000,000. So that's why we say from positive infinity to from negative infinity to positive infinity. Does it make sense?
Yes, ma'am.
Okay, and then the intercept obviously makes sense. This graph by looking at it. Your y-intercept is 0, and then your x-intercepts are 0, 180, and 360. Makes sense, right?
Yes, ma'am.
Thank you. And then again, the asymptotes are 90 and 270. These are points where the graph is undefined. Yes. And then again, we're going to look at how our A and our Q changes our graph. So obviously it's going to be different for the 10 graph because we don't have waves that we are used to. So the Q still does the same thing. Shifts it vertically, whether it's upwards or downwards. Now you'll see a vertical shift in the graph. So if again we have positive Q, so Q is greater than 0. So for Q is positive, the graph will be shifted upwards. So as you guys saw the original graph, it starts at 0. So if it was 10 theta plus 2, then the graph would start at 2. Would see a vertical shift upwards. And then for Q is less than 0. So when Q is negative, we'll see a shift downwards.
Yes.
Does make sense.
Yes.
And then A affects the shape. A affects the shape, as always. So let me so that you guys can see. So when A is greater than 1, the branches of the graph are steeper. So steeper means narrower. It looks narrower and not wider. And then when it's between 0 and 1, they are less steep and more curvy. And then same as the cost graph and the sine graph, when A becomes less than 0, you see a reflection. about the x-axis. As you can see here with the graphs drawn, can you see here for a is less than 0, the graph faces that way, but here it faces that way. You can see that these graphs are a reflection of each other. I hope that makes sense.
Yes, ma'am.
Unfortunately, I can't explain the steeper parts because they don't have values here. But you guys can take a screenshot. What? Did you guys take a screenshot? Sorry. Did you guys
Yes.
take a screenshot? Okay. So I want us to do an exercise. Ne? Each person is going to get their own question to attempt. So we have 30 minutes to try and cover everyone. Okay, can you guys see my screen? Can you guys see my screen?
Yes, ma'am.
Okay, let me see on the participants list who's number one. Number one is Chuma. Chuma, you ready?
Oh, okay, ma'am.
Okay, read your question. So it says, in the diagram below,
Yes.
graph of g of x is equal to cos x plus 30, and it's drawn for the interval from negative 300, or where x is greater than negative 300 but less than 420. Now, so your
Yes.
question is, determine the maximum value when we have hx is equal to cos x plus 30 minus 2.
Yes.
So what do you notice about the two equations? What's the difference?
Ma'am, can you please repeat what you said?
What is the difference between the equations of g of x and h of x?
G of x, I think it's decreasing, and h of x.
Look at the
Is
two
it-
equations and tell me what's different between the two of them.
Okay.
No, look at the formula. What is different? The formulas look the same, but what is different? What is different?
The difference is I think the difference is that g of x increases and h of x decreases.
Okay, no, try again. Look at their formula. G of x is equals to cos x plus 30, and then h of x is equals to cos x plus 30 minus 2.
Oh, the difference is that g of x doesn't have a minus 2, and h of x has a -2 at
Okay,
the
so
end.
what does the -2 mean? What does it mean?
I think it means that the graph will the graph will
The graph did what?
I think it means the graph will increase.
Is it?
I'm not really sure.
What does the Q value do in terms of the graph? What does the Q value do? Okay, let's ask someone else. Mbali. Mbali. Mbali, are you here? Yeah, okay. Felicity.
The Q in a graph, it means the graph either shifts up or down.
Okay, so now we have -2. What happens to the graph?
It shifts down by 2 units.
I'm back, ma'am.
By 2 units. Okay, so when we move, so the graph of g of x was drawn, right? And you can see what is its maximum value. What is the highest point in this graph?
2
1.
and
1.
1.
Correct. 1. So when we move it down, wait, who's answering? Wait, Mbali, wait. Felicity's answering.
Okay.
You answer another question. So when we move it 2 units down, what is going to be the maximum value?
-1.
Let's see. Correct. Well done. Okay, next question. Nigel. Are you here?
Yes, ma'am.
Okay. So unfortunately, you have 2 questions. Sorry. In the diagram below, the graphs of f of x is equals to sine x and g of x equals to cos bx are drawn. And then the interval is x is greater than -540 and less than 630 degrees. So according to the key, the red graph is f of x, and then the blue graph is g of x.
Yes, ma'am.
The first question is, what is the period of g? What is the period of g?
Let me check, ma'am.
Before, define period for
720, ma'am.
720.
Yes, ma'am.
Okay, and then
700.
what is 720? Okay, and then what is b? Let me come back up.
B, it's I think it's 360, ma'am.
What is it?
360.
Is b not an integer? Hmm? I'm asking.
It is, ma'am.
So do you want to change your answer? Or you want to keep it the same? Do you want to keep the same answer or do you want to change it?
Yeah, I want to keep it, man.
I want to keep it. Okay.
Yes.
So you said 360.
Yes, ma'am.
Why do you think you're wrong? Read the solution, Nigel.
Ma'am, starting from the number of degrees,
Yes.
the number of degrees between these 2 points is 360 minus, in bracket, minus 360, which is equal to 720 degrees. So a full period must be double this, which is 1440 degrees.
Hey, does it make sense? Or do you want me to explain?
Yeah, ma'am.
I must explain.
Yes,
Yes.
Yes.
Okay. Let me go back up here. Ish, let me see something. Ish. I can't edit. I'm gonna have to stop sharing. Okay, I'll just show you guys here.